In this chapter of CIS 1103, this is week 8, we will cover the TCP IP model. Okay, the TCP IP model, first of all, how many layers in the OSI model? 7. In the TCP IP model, some books says it's 5, some books says it's 4. We will follow our book and our PowerPoint. So it's four layers. Why it's not coming? Yeah. All right. Okay. So these are the layers. Okay, these are the comparison between the TCP IP model and the OSI model. The OSI is 7 layers, TCP IP is 4 layers. The top 3 layers in the OSI, which is application, presentation, and session, they are combined in one layer called application. Then the transport is the same transport. The network layer in OSI is now called internet layer. The data link and the physical layer are combined into data access layer. Okay? Any questions about that? The access layer is important for us, especially when we are designing our LAN and WAN. The access layer devices provides access so hosts can join a wired or wireless network. In a wired network, you have each device is connected to a switch. Okay, a switch is a layer network device. Okay, a switch is as a layer network device. A router is a internet layer device. Okay, don't forget this, please. A switch uses the MAC address table, okay, to send the message to a specific port. And if you look at this diagram, each port is connected to each device, H1, H2, each one is connected to a unique port on the switch. Okay, so when the switch receives a frame, it will look at the destination MAC address, to which this destination MAC address connected to which port, and then it forwarded to that port. Okay. If it does not have this device, it will do a broadcast to all the ports except the originated port. Okay, again. So the switch receives a packet, a frame from H1, and the destination is the MAC address of H7. So the switch knows from its MAC address table that, okay, H7 is connected to my port number 7. Okay, so it will send it to that port only. But if it receives from H1 a frame, and let's say it is connected to, and it is addressed to, let's say H9. We don't have H9, so what it will do, it will broadcast this to all the computers except H1. Okay. This is the MAC address table. This is an example. So you have each port FA, yani fast Ethernet 0/1, and it is connected to this device MAC address. This is a MAC address of, let's say, H1. Then I have port number 2, fast Ethernet 02, connected to this is MAC address of computer 2 or H2, and so on. So when you switch on the switch, when you turn on the switch, it will build its MAC table, okay? Or we call it MAC address table or the switch table. So a switch forwards a frame out to a specific port when the destination MAC address is available in the MAC address. It will forward out to all hosts when the destination MAC address is not in the MAC address table. Okay? So this is how it is done. Any questions about that? All right. Now here we have an important topic. This is very important, please. You get questions like this in quiz 2, okay? Broadcast containment. The switch is available in the LAN. As I just mentioned, there are some broadcasts that are going in the LAN. How do we contain, how do we prevent these broadcasts to go outside to the world or to other LANs that does not belong to us? The firewall will block these broadcasts, or it will contain the broadcast. So the firewall prevent or stops broadcast. In other words, the whole network here, how many broadcast domains here? In this network, how many broadcast domains? Do I see any router? Do I see any router here? Yeah. No. This is a switch. So here we don't have any router, so this is one broadcast domain. One broadcast domain. What about this one? One broadcast domain. Okay? Because the switch allows broadcast. In the next slide, a broadcast domain is the area through which a broadcast message can travel. Each local network is a broadcast domain by itself. Routers are used to divide the network into multiple broadcast domains. Okay, so in this diagram, how many broadcast domains is there? Put your hand up if you know the answer. Yes? 3. Any other answer? Yes, it is 3 domains. Very good. So each interface of the router is connected to one broadcast domain. Okay? And the last slide in this chapter. Access layer communication. In order to send information from a device that is on an Ethernet network, the device must supply its own MAC address, destination MAC address, its own source IP address, as well as a destination IP address. If I have the IP address but I don't have the MAC address, how do I do that? How do I get the MAC address? By using Address Resolution Protocol, ARP. ARP discover the MAC address of a device on the same local network. Okay? Thank you. Any questions?